So, thank you very much for the introduction. Yeah, we are picking up a topic which I think is related to testing, but also picking up the topic that we concentrated on last year, which was on energy and energy efficiency. And I have to say, if something hasn't changed, at least in my daily business in the past year, then that's the attention on energy efficiency, energy reduction in any parts of the network. And so this is why I'm very glad that we now have a couple of about 20, 25 minutes, I believe, to talk about specifically, again, this topic of energy efficiency, what has happened. And I'm very glad that here on the panel, we have, I think, a small, really production chain along the ORAN networks, mobile networks, from components, systems, towards the apps. And that's why I'm very glad that together with you, we will now be able to discuss this topic. And yeah, in order to kick this off, I would be grateful if you have a brief introduction, 1 to 2 minutes, and what your connection to the ORAN community and energy efficiency is.
Sure. Yeah, thanks. Thanks, Michael. So my name is Neeraj. I came from the Santa Clara, California, work for Dell. And part of the my team is actually, the Dell has created a lab called the Open Ecosystem Lab. And from last few years, we are trying to figure that out as part of the ORAN. It mentioned basically disaggregation, where how the hardware is actually catching up to. So if you talk about the energy efficiency, everything matters basically. Every watt matters, and we basically trying to validate that how when you're trying to run the stack basically on a particular platform, is it up to your mark or not, and what are the gaps if you are compared with the traditional RAN, and what is that parity and what exactly we have to do. So I'm going to talk about that a lot. And in order to that, from last few years, I also created two white papers and mention about a lot of details in that, what's going on.
Okay.
Yes.
Thank you, Neeraj. Alberto.
Yeah, Alberto, working for Analog Devices. Analog Devices is a global semiconductor leader. One of our big focus areas is chipsets for mobile radios in the world, Open RAN and non-Open RAN. We are very much involved in power. It's one of our priorities. If you're looking at a network today, about 70% of the power goes into the radio. And then if you look inside the radio, 70% goes to the PA. So having a good chipset on and trying to save power is very relevant and can save a lot of power. And by that, TCO, because that is, if I talk to operators, it is always about TCO. So myself, I'm leading a systems team. I'm about 30 years, a little bit over 30 years in this industry. First 15 years in handsets, last 15 years in infrastructure. So,
Okay, thank you, Alberto. Marcin, over to you.
So I'm Marcin Hoffman. I'm a technical solution manager with RIMEDO Labs. And with RIMEDO Labs, we are, let's say, an R&D powerhouse. So our main focus are XApps and RApps, but we also offer some training, so applied to research projects. And we are the part of the ORAN Alliance, part of the IARAN Alliance, and with our projects we are cooperating, of course, with the T-Labs, with the I14 Pi Labs, who invited us here. Yeah, but also we had a cooperation with Juniper Rig, where we implemented our apps, and with Keysight and Viavi, who offer the testing services to test our applications. So regarding the energy efficiency, we are having a few XApps and RApps that takes the problem from a little bit higher perspective than Alberto mentioned. So we are looking for the network as a whole, so how to switch off the cells depending on the traffic, or how to reconfigure the number of active antennas in massive MIMO, and how to do it using the rig and XApps and RApps.
Okay, thank you. So, gentlemen, to get the discussion further going, I was wondering whether your global view. I mean, you're representing really, I think, global companies, and you have a view on what's happening across the different industries and continents. What is your view on the role of energy efficiency? Sometimes from the kind of German, European perspective, I thought this is a very specific European kind of topic related to public networks. Is this the right perception? Or do you perceive this as a different discussion also in other parts of the industry?
It is. It's certainly it's plays a very key role, and without having the system very efficient, I don't think this technology can make it. And it is very important that to make sure that starting from the radio and to the stack hardware that hosted the RAN stack and plus all the backend components, they are all very energy efficient. But how do we measure really? That is one of the critical part. And that's where I will reveal a lot of information about it and how industry is basically making improvements. And especially Dell and Intel also kind of, making efforts to make this as successful. So that's where I stand currently, and I will basically provide the more information after that, and please for the next question.
Okay.
Yeah, I think there are two parts in this question. Yeah. So one part is geographically, is there a difference? There is, but in both, all over the world is important. If you're looking at the electricity costs in Europe, they are higher than in North America, for example, and that has an effect on your total cost of ownership, and that makes your balance slightly different on how important it is. But again, in public networks, I see that request back everywhere. If I'm going then to private networks, I see absolutely a different balance there. Because if you are a factory owner, for example, you're going to install 5 small cells, it doesn't really have that much big of an influence on your electricity bill. You have heavy machinery there, that is really your electricity bill. Also, your total cost of ownership there is probably much more around servicing and other places than the electricity, which is, for an operator, one important part, the electricity bill. So I do see importance, but especially between private and public network, there are differences which are substantial.
Okay, thank you, Alberto. Marcin, your view.
Yeah, so I think I will mostly agree with what previous speakers said, that it depends somehow on the region. So probably in Europe we are a little bit more focused on that. Maybe in US a little bit less, but I think that if this energy efficiency brings money to the operator, then it is a good case and it is important. So I think this is how I see that, and I see that it might also be interesting to take into the account the XAPs and optimization algorithms itself, and especially if they use some big AI models, and then to consider if really the power that is consumed to run these models and the effort that or servers that requires to run the optimization algorithms, does it bring the benefits in overall, yeah? Or not to spend too much energy on energy efficiency optimization algorithms. But it might be an interesting case also to look at.
Okay, thank you. So I think we have also the privilege of you gentlemen having views and experiences from, let's say, at least two sides of the industry. One is, let's say, also you're dealing with, let's say, traditional mobile networks and operations, SRAN as we would call it, I think these days, and also O-RAN. So from an energy perspective, do you see any differences, potentially any advantages of the Open RAN architecture compared to SRAN?
Yes, certainly there are. The whole design and whole idea is basically of the Open RAN and O-RAN, you call it. It certainly is being the more flexible, more dynamic, and more energy efficient, because so much capability. If you compare it with the traditional, which is monolithic and static and not much you can do, here is you have a lot of flexibility and so much innovation in every part going on. Overall, basically everybody's effort is to going into the same direction, and then they have to achieve basically better than what it used to be. And certainly, let me give you an example basically here. So I started a 5th gen server, XR11, Dell provides, which uses a 3rd gen Ice Lake CPU. And we did some RAN workload on that, and then we compared it with the next gen 16 gen hardware, XR8K, which uses the Sapphire Rapid 4th gen CPU. What we have seen, the capacity of the spectrum processing capacity is doubled, okay, and plus the energy efficiency we gain around 15 to 20% for the same workload. So the kind of the improvement going on, and plus now we are waiting for the Granite Rapid. You must have seen that GNRD. That is the next CPU is coming out, and which will double the processing capacity of the CPU again. So earlier you used to do the 10 cells, let's say 44R. Now you should be able to do 20 cell, and plus it will give you another 15 to 20% another basically efficiency, power efficiency gain in that. So overall curve is basically efficiencies keep on growing and capacities keep on growing, but the overall cost basically will go down for hosting the entire workload.
Okay, thanks. That sounds very promising. Alberto,
Yeah, I totally agree, by the way. It's a very good answer. I would like to add that what I like about Open RAN in general is the ecosystem from universities, institutes, startups, and established companies working together. I believe that creates a better innovation environment than just a single company. Not a single company in the world is good in everything. So that I really like of Open RAN, and that's a great opportunity. Now that said, what I would like to see, so if we are looking in my own situation, the radio chipset, we can do a lot and innovate there a lot. Then we are looking isolated to a radio. Now what I've learned in handsets in the early days, we did make the big progress on battery life for a handset when we started to look at the system level, not at component level. So if I'm looking at a RAN, there's where we can win. And unfortunate, Open RAN didn't specify, I think, yet enough to be able for us to, for example, use X and R apps. Because if we use R and X apps from one company, it doesn't justify if not all X and R apps has the same interface. And I think we can do better. I know in Work Group 6, Work Group 7, there are absolutely good discussions ongoing, initiatives. But I think there we can, as an ORAN community, do better.
Okay, thank you very much. So before we move over to you, I think it's a good point, because this was something that I observed when we were preparing this panel, that somehow one thing we do in this community is anyhow talk with each other and exchange information. But I think we not only need this between the, let's say, developers and promoters, but also on the systems. So if you were to have a wish what to do better or what to improve, where are the kind of interfaces also between your different parts of where you work in the bits and pieces of ORAN, where you would hope for, let's say, better exchange of information or better interfaces in order to improve, for instance, energy efficiency?
Yeah, so I think a very big wish, and I think we also talk a little bit about that during our morning discussion, is the maybe not interface itself, but I mean even bigger principle, that availability of the data. So because okay, there is some demand from operators or our customers, so show us that your solution, your XApp or your hardware or something brings energy efficiency benefits, and like show us on the real world data. And we'll be really happy to show that on the real world data, but then it comes some, of course, justified legal issues and so on with sharing the data, but it then stop us from testing our solution on the real data and to demonstrating the benefits. So I think if there was some wish on our side, it was the wish to have more data from the real deployments public, so we can train our models, we can verify them, build some digital twins to test their impact on the network, and yeah.
Okay, thanks.
Want to add to it?
Yes, please.
So certainly, I like that idea, ORAN supports that there are interfaces provided to manage the power. And the good thing is that using that interfaces, you basically, Like if you take the architecture of the XR8K, which is the slate-based server, so you might have multiple slate in a single chassis. And you know that every day the load basically does not remain consistent. It goes peak, and then during the night it goes basically off peak. So it basically vibrate like sinusoidal kind of thing. So you can take the advantage of that using these API. So you can offload from the your workload from particular sled to another sled when during the off-peak time. That will basically give you the tremendous amount of power saving. So that is the architecture like going on for the cell site for DRAN especially, and that's where all these APIs will be very helpful. So how do you dynamically maintaining and shutting down the the power system that is not required. The radio is like cell is certainly one of the thing, no doubt, that transmitter, TRX chains and all those things. But how do you handle the server side? That exactly I'm talking about. So you can do basically shut down the power of the particular sleds and offload. Before you do that, you offload the basically workload from that to another one. So that's how you get basically an energy saving.
Okay, thanks. Alberto,
I want maybe it's a little bit slightly different discussion, but if I'm talking with my colleagues in analog devices on data centers, I'm really jealous the amount of data they have about power distribution. We get from operators like DT and Telefonica, Vodafone. You do your best, but basically it is very, very, very basic information we are getting. And with that, we need to do algorithms. We have in our chipsets machine learning algorithms, but we have to do that basically on hardly any data. So if we could improve that in the standard, in a way that we're really going to measure. If I look at data centers, they are measuring and they are putting their cooling connected to that. They do maintenance schedules for that. They are looking at backup solutions, resilience. So there is a lot with that data to be done and optimized. And I think there absolutely we are. And we can learn a lot. Maya, you mentioned intelligent copying, I think it was, right? Go to data centers and let's intelligent copy this. I would say, absolutely.
Okay, yeah, thanks. So I think there is quite a big plat for this kind of sharing more of data and information. So this is something that I took away from our initial discussion already. I think it's a topic that also close to my work because we are also depending as an operator on the own data that we see. And one of the observations that I made the last couple of months was that, for instance, if we look at standard information from our systems, it's typically in 15-minute intervals, something like this, that we get. And we honestly turned to our colleagues in the i14Y lab and we're asking whether we have any other timescales we could get down to, so with a higher granularity. And they said, well, yes, of course. Yeah, so Neeraj, for instance, told us, yeah, so there's a whole list of things that I can get from a Dell server per standard, and they just need to trigger the request, and off we go. So I think there is quite a discussion to be led also in this industry, and maybe that's one of the advantages then of All-Run versus some of the other designs, that there is more interest in this data, and potentially there is more also participants in the market who somehow can deal with the information that is provided from the system, in whichever way this is being generated. But this is one of the takeaways from me, honestly, from the discussion we are having, as we are, I think, approaching the time limit of our discussion, which I think we could continue for quite a while, at least I could. I was just wondering what would be kind of your takeaways, or what would be the one request that you would have to the community for energy efficiency, what to do next?
Well, there are more things you can do on the server side I want to talk about, and especially dealing with the C states. So if you are running RAN stack, okay, and they are tied to a specific course and some of the cores are not being used, you might put in the C6 state. So that will put them in the deep sleep, and that give you the extra benefit of the power saving. So what I have seen so far, if you're running 1 cell to 6 cell, let's say, and like load goes up and down, and you can basically trickle down your cells kind of thing if you do all those things. So what I've seen, fair easily you can take 25 watt to during the off-peak hours up to the 5 watt fair easily, like all the cores that not being used during those processes putting in the C6. So that's the extra advantage. That's the one thing I want to talk about. And another thing, the technology like low-side and inline is also like in the kind of people talk about. And what we have seen, we have analyzed both of them, and certainly there's our advantage of for both technology. So it has to be used very wisely because they fit in certain category based on the energy efficiency. If your spectrum is number of cells or whatever you call that, it's not that pretty high. So look aside, it looks more prominent on that for energy saving perspective. If you go more higher and higher, basically dense, then inline is give you more beneficial. So these are all kind of the tools that in your hand. So where overall, performance per watt, every watt matters, and you have to look on every point everywhere, then where you can save more and more energy. Overall, all the game is then, this is a single site we're talking about. If you combine all of them together, then that's where you basically algorithm, data, and all those things comes in the picture, how it can be playing. Every site has a different environment. The off-peak for one site may not be same for another one, and so the engine will be complicated, no doubt that. So that's the reason I agree with all the data collections and the algorithms you're trying to talk about.
Thanks. Alberto.
Yeah, I think first of all the topics we have discussed in the last 22 minutes are relevant. Well, one specific point as an example is latency and slicing, because the most efficient way to reduce energy is just switching things off. We all know that. Now, what if you have very low load? You get all your symbols in. Do you really need to send it out immediately, or you wait? Basically you put your bucket full and then you send it at once. If you can do that, of course you create latency. So how much latency is acceptable, and these kind of discussions of what could you do there, I think you can gain a lot of power efficiency, and by offering different slices, like for example Deutsche Telekom is doing with low latency and gaming, then you can ask people that really wants low latency and a higher price, but it also will cost more energy. So this kind of discussions at a system level definitely can help us to save even more.
Okay, thanks. Marcin.
So I think on our end, such a wish or what we can do for energy efficiency would be very nice from our perspective to get all these things together, all these servers and radio units and hardware, and put the rig on the top of that and really try to build either here or with cooperation I14Y Lab with T-Labs to build start to building, like going out from the emulations that we did, that we verified our algorithm with Viavi, with Keysight. We show some benefits to really deploy something and try to see what are the to build the Oran stack and try to measure something really really real and see what the XApps and RApps can bring on the top of that.
Okay, Marcin, thank you very much. Alberto and Neeraj, was a really pleasure to have you here. I could go on for quite a while, but I think we have other topics now to deal with. So I think we are done with our panel. Thank you for listening to us, and hope to pick up discussions also in some of the offline discussion situations during lunch and coffee break.
Thank you, Mike.
Thank you.